In this video, we'll be talking about rotations, specifically rotations about the origin. If you're curious about rotations about a fixed point, I'll go ahead and link those videos either in the cards or in the description down below so you can watch those. Let's begin with some rotation rules for the most common rotations. First one is 90 degrees clockwise, which is the same as 270 degrees counterclockwise. And so let's say that I started out with a point, let's say A, located at x, y. If I wanted to rotate this point A 90 degrees clockwise about the origin, my new point would then be located at, let's say, A prime, y, negative x. And so what I do is I switch the locations x, y, and I stick on a negative sign for the x. And so to kind of draw it out so that you can have a visual understanding of this, let's say I had a point located here, A, at x, y. I want to rotate this 90 degrees about the origin. So 90 degrees looks something like this. And so this point, A prime, would be located at y, negative x. This is a 90-degree rotation clockwise, or it could have been a 270-degree rotation counterclockwise. The second rule, 180-degree clockwise. And this is the same as 180 degrees counterclockwise. And the rule for this rotation is really simple. If I start out at a point A located at x, y, my new point would be at A prime located at negative x, negative y. So you just take the opposite of the x and y coordinates. Let's give this guy some space. Give this guy some space as well. Let's say we had a coordinate plane, something like this. Suppose I had the point A located at x, y. Well, 180 degrees, that's a straight line. And so if I want to rotate 180 degrees clockwise, I would end up somewhere right here. This would be A prime. Or I could similarly rotate 180 degrees counterclockwise and still get the same A prime. And the last rotation rule would be 270 degrees clockwise, which would be the same as 90 degrees counterclockwise. And so let's say I started at a point A located at x, y. My new point after a 270 degree clockwise rotation, I would end up at A prime located at negative y, x. And so I switch the two coordinates, x and y coordinates, and then I take the opposite of the y coordinate. Let's go ahead and box these rules because they're pretty important. We're going to use them in the following exercises. We're going to use them in the upcoming examples, so keep this piece of information handy. Let's do some examples. In this first example, I want to rotate about the origin 90 degrees clockwise. So this first figure is a triangle with vertices A, B, and C located at 2, negative 3, 2, 4, 1, 3. Now if you remember, or if you've written down the rotation rules, then whenever you rotate a figure 90 degrees clockwise, what happens is the new point, you switch the order of these two coordinates, of the x and the y coordinates, and then you take the negative of the x coordinate. So A prime becomes negative 3, 2, but remember this was the original x coordinate, and so we take the opposite of that. So we get negative 3, negative 2. B prime, or the new location of B, we switch the orders of 2 and 4, but remember, we have to take the opposite of 2. So it would become 4, negative 2. C prime, We switch the orders of 1 and 3, so it becomes 3, 1. But remember, we take the negative of 1, and so we get 3, -1. And so these are my new coordinates for my new rotated figure. Let's go ahead and draw this so that we have a visual understanding of what's going on. I'm going to use blue to draw the rotated figure located at -3, -2. This is A prime. B prime is located at 4, -2, which is right here. B prime. C prime, which is located at 3, 1. Sorry, 3, -1. For a second there, I thought it looked kind of funny. And so you see, from here to here is a 90-degree clockwise rotation. From here to here is also a 90-degree clockwise rotation. And from here to here is also a 90-degree clockwise rotation. And that's how you do this problem. Let's go ahead and do another problem. In this problem, we'll be rotating a figure 270 degrees clockwise about the origin. Again, we have another triangle located at A, which is at 2, -5, B, 4, -4, C, 2, -1. So let's recall our rotation rules. For a rotation that is 270 degrees clockwise about the origin, all we have to do is switch the x and the y coordinates, the placements of the x and the y coordinates, and then we tack on a negative for the y coordinate. And so what we end up getting for A prime is -5, 2, but remember we have to take the opposite of the y coordinate or the original y coordinate. And so this is simply 5, 2. B prime, we switch the locations of 4 and -4, and that would make it -4, 4. But remember, the original y coordinate, we have to take the opposite of it. So it would be +4, 4. C prime, we switch the orders of 2 and -1, but this becomes positive, so it becomes 1, 2. So let's go ahead and graph this so that we have a visual understanding of what's going on. So here's my coordinate plane. I'm going to start out by drawing my original figure. So A was located at 2, -5, which is right here. B is located at 4, -4, which is right here. C was located at 2, -1, right here. So this is my triangle. And in blue, I'm going to draw our rotated figure. So A prime is located at 5, 2. B prime is located at 4, 4. C prime was located at 1, 2. And so this is my new figure. And if you can see, in order to get from the original C to the new C, this looks like a 270-degree rotation, clockwise rotation. And that's how you do that problem. If you enjoyed this video and found it useful, please give it a thumbs up, comment down below what topics you'd like me to cover next, and hit that subscribe button for more. If you really enjoyed this video, consider becoming a supporter of my Patreon, which helps me continue to make useful videos such as this one. And go on to my website for more math-related art, articles, blog posts, worksheets, and more. Thanks. See you in the next one.